Hello, hi, I am Omer Nisar. You are watching my YouTube channel, Think and Grow Rich with Omer Nisar. Dear students all over the world, from all over the globe, of the students of the physics, I come here especially for elastic collision in one dimension. In this lecture, in this video, we will discuss elastic collision in one dimension. Through length and breadth, we will discuss whole of the aspects, whole of the concepts, whole of the things about elastic collision in one dimension. So what is elastic collision? The collision in which two bodies collide with each other in such a way that the kinetic energy or momentum both will remain conserved in the collision is called elastic collision. Since it is in one direction, in single direction, say it is along x-axis, so this is elastic collision in one dimension. So what we mean simply here, the collision, as we know that when we are moving on a road or when children are playing or in a billiard game, what happened when two bodies collide? For example, a car collide with a car, or a bus collide with a car, or a motorcycle collide with a bus. So whatever the collision is all about, whether bus collide with car or car collide with motorcycle, or when children are playing with each other, running themselves towards, whether they collide, then this is the topic. We will discuss elastic collision, inelastic collision. So let us start. What is this elastic collision in one dimension? What elastic collision is? The collision in which both kinetic energy as well as momentum remain conserved is called elastic collision. This is called elastic collision. Since it is in unidirection, it is in single direction, say it is along x-axis, so it is called elastic collision in one direction or one dimension. So this is the topic, elastic collision in one dimension. The collision in which momentum as well as kinetic energy remains conserved in unidirection or in one direction is called elastic collision in one dimension. So let us come next. Since both momentum and kinetic energy of the system or bodies remain conserved, so we apply here conservation of momentum as well as conservation of kinetic energy. Let us see. It is m1 moving with velocity v1, m2 with v2. This is before collision. And after collision, when they collide and apart from each other, so this velocity v1 was changes to v1 dash, changes to v1 dash, and v2 changes to v2 dash. So this is now we find conservation of momentum equation. What it say? Total momentum before collision is equal to total momentum after collision. So what is the momentum of that bar? m1 v1, that bar m2 v2. Since it is before collision, so what is m1 v1 right here, m2 v2 right here. So total momentum, we will say that add these m1 v1 plus m2 v2, add these. So by adding it becomes total momentum before collision is equal to, now momentum of this body m1 v1 dash, m2 v2 dash. Since total momentum, so add m1 v1 dash, m2 v2 dash, so add. So this is momentum before total momentum before collision is equal to total momentum after collision. This is conservation of momentum equation. Now let us come here, conservation of kinetic energy. What it say? Total kinetic energy of this system before collision total kinetic energy. So what is half m1 v1 square? What is the kinetic energy of that? Half m2 v2 square. What is total? Total will be half m1 v1 square. That is the kinetic energy of that body. So of that half m2 v2 square, what would be the total? Adding this half m1 v1 square plus half m2 v2 square. So plus mean energy of that mass plus energy of that mass being total energy of that two bodies before collision is equal to half m1 given dash square plus half m2 given dash square. So total energy after collision. So after collision total energy. So these two equations are the main equations in elastic collision in one dimension. So let us come to the very important point. One must remember that momentum is a vector quantity while kinetic energy is a scalar quantity. So momentum, due to its vector property, due to its direction, can be resolved. So momentum in all cases, whether elastic collision in one dimension or elastic collision in two dimension or inelastic collision in one dimension or inelastic collision in two dimension, momentum in all cases will remain conserved or constant. While on the other hand, kinetic energy, since it is a scalar quantity, it may or may not remain conserved depending upon the nature of the case, whether elastic or inelastic. We will discuss all these properties, all these things in the very next lecture, in the very next video. But here, one thing that must be kept in mind is that momentum remains conserved in all the cases, in elastic, in inelastic, in two dimension, elastic collision, or inelastic in one dimension, etc. While kinetic energy may or may not remain conserved depending upon the nature of the case. Thank you for watching my video, and we will meet in the next video. Thank you.